And welcome to our today's class. It is our second lesson on the topic cells and symbol circuits. So let me begin by giving you the quote of the day, which states that if it does not challenge you, then it will never grow you. If it does not challenge you, then it will never grow you. So we'll discuss that quote at the end of our class today. So today we'll be looking at electromotive force and potential difference. That is, we want to know the difference between those two. So current flows through a conductor because of the difference in the electrical potential, which we are calling the potential difference, which is produced by a cell or simply a number of cells, which is actually a battery. So a battery is formed by a number of cells. That is when 2 or 3 cells or even more cells are arranged in a series, then we form what we call a battery. So now, what is electromotive force? So we are saying that the work of the battery is simply to pump the charges into the circuit, but charges cannot be pumped into the circuit when there is no what we call the potential difference. So that means there has to be a region with higher charges, which is of course the source or simply our cell or even the battery, such that it pumps charges to regions with low potential difference or voltage. So that difference is what we are calling the potential difference. That is, charges will always move from a region where they are more to a region where they are less. So we are saying that current flows through a conductor because of the difference in the electrical potential, which we are calling the potential difference, which is produced by either a cell or a number of cells arranged in series, which forms a battery. Now the battery actually pumps the charges in a circuit, and we are saying that the total energy supplied by the battery is what we are calling the electromotive force. The total energy or the total charges supplied by the battery, that is before they are lost due to resistance, is what we are calling the electromotive force. Then the potential difference, that is now the amount of energy or charge that remains after some energy has been lost due to the resistance of the materials and even the internal resistance of the cell. Now the potential difference is measured by an instrument called a voltmeter. This is what we are calling a voltmeter. Remember, a voltmeter will always measure voltage in volts. It measures voltage in volts. So in short, we are saying that E.M.F of a cell, that is, E.M.F is the short form of what? Electromotive force. So we are defining electromotive force as the voltage across the terminal of a cell when it is not supplying any current in a circuit. So electromotive force of a cell or E.M.F of a cell is the voltage across the terminals of a cell when it is not supplying any current in a circuit. That is in this manner. So the circuit here is actually open, meaning the amount of charges or current coming from the battery, it does not get to the bulb, because when it gets here it finds that the switch is open, therefore the circuit is open, and therefore the amount of current does not actually flow to the bulb. So there is no actually energy lost to the bulb, because current does not go through that bulb, which of course has some resistance. So the amount the voltage, remember the voltmeter here measures the voltage of the battery here, or our cell here. So the voltage across the terminals of a cell when it is not supplying any current in a circuit is what we are calling electromotive force. Then we can also define electromotive force as the voltage across the terminals of a cell in an open circuit. Is the voltage across the terminals of a cell when the circuit is open. The voltage across the terminals of a cell when the circuit is open. So when the switch is open this way, this is what when we are saying that the circuit is actually open. So it is also important to note that the electromotive force will always be greater than the potential difference. Why? Because for electromotive force, the current does not flow through, or the charges does not flow through to other components. That is, the initial amount of charge that was in the battery is measured when the circuit is actually open. So electromotive force can be defined in two ways. One is that electromotive force of a cell is the voltage across the terminals of a cell when it is not supplying any current to the circuit. Or electromotive force of a cell can also be defined as the voltage across the terminals of a cell in an open circuit. So you can see in this case the bulb is not actually lighting because there is no current being supplied to it, because the circuit is actually open, or the switch is open here. Then 2, we look at what we are calling the potential difference. So we usually denote it by PD, P for potential and then D for difference. So the PD. So what is the potential difference? So we are saying that the potential difference, this is the voltage across the terminals of the cell when it is supplying current. Potential difference is the voltage across the terminals of a cell when it is supplying current. So you see in this case the circuit is actually closed, or the switch is closed, meaning the amount of current actually coming from the cell here is passing through the bulb. So that current is used in lighting the bulb. That's why you are seeing the bulb in this case is actually shiny, or it is producing some light. So there is some amount of voltage that is lost in this bulb, and even due to the internal resistance of the cell itself. So the amount of voltage across the terminals of a cell when it is supplying current in a circuit is what we are calling the potential difference. So that tells you potential difference can also be defined this way: is the voltage across the terminals of a cell in a closed circuit. The voltage across the terminals of a cell in a closed circuit. Now, so it is important also to remember that the value of the potential difference will always be less than the value of the electromotive force. But the question is why? So remember, for potential difference, we have the internal resistance of the materials of the cell. So because of that internal resistance and even the amount of voltage that is lost through the other components, for example the bulb here, so because of that reduced voltage due to internal resistance and even the loss of energy through the bulb, that is what makes the potential difference to be lesser than the actually the electromotive force. Remember, for electromotive force, you are measuring the initial voltage, the initial voltage of the cell before it is connected to other components or in an open circuit. But for potential difference here, the circuit is actually closed, meaning current is flowing to all other components. Therefore, we have voltage that is being lost due to the internal resistance of the cell. That's why the value of the potential difference will always be less than the value of the electromotive force. Now remember, a dry cell, when it is new, we expect its voltage to be actually 1.5 volts. But when we measure the potential difference, that is when it is connected to other components, for example the bulb, actually the potential difference drops from the from the E.M.F, which was 1.5, then it comes to 1.4. So the amount of voltage lost, that is 1.5 minus 1.4, which comes to 0.1. So the 0.1, that one we call it the lost voltage. We call it the lost voltage. So we are saying that potential difference is measured in volts by an instrument called a voltmeter. Then although both E.M.F and potential difference are measured in volts, the potential difference of a cell is different from the E.M.F, or the electromotive force of a cell. So the E.M.F of a cell is the voltage across the terminals of a cell when it is supplying no current in the circuit, or the voltage across the terminals of a cell in an open circuit. Whereas potential difference of a cell is the voltage across the terminals of a cell when it is supplying current in the circuit, or when it is in a closed circuit. So the difference between the reading, that is the difference between the E.M.F, that is for this case our E.M.F is 1.5, then the potential difference is 1.4. So the difference, that is 1.5 minus 1.4. So the difference between E.M.F and the potential difference is called the lost voltage. And we have said that the lost voltage comes as a result of opposition of the flow of charges within the cell. So the lost voltage is resulting from opposition due to the flow of current within the cell, or what we simply call the internal resistance, what we call the internal resistance of the cell. So we've just said that you can differentiate between those two in this manner. So if you are asked to state the difference between EMF and potential difference, you say one, EMF is the voltage across the terminals of a cell when it is supplying no current, while potential difference is the voltage across the terminals of a cell when it is supplying current to a circuit. Another way of differentiating those two is that you can say electromotive force is the voltage across the terminals of a cell in an open circuit. The voltage across the terminals of a cell in an open circuit. Whereas potential difference is the voltage across the terminals of a cell in a closed circuit. In a closed circuit. Then two, we look at connection, connecting cells and even bulbs. So let's start with the connection of cells and bulbs. So cells can be connected in two ways, either in series or in parallel. So let's start by discussing series connection of cells, or when cells are connected in series. So when do we say that cells are connected in a series? So when two or more cells are connected such that positive terminal of one cell is joined to the negative terminal of another cell, then the cells are said to be arranged in series. That is, for example, in this case we have two cells here. One is this one, then we have another cell here. But you see the negative terminal of the second cell, this is the positive terminal of the second cell is connected to the negative terminal of the first cell, whereas the negative is also connected to the positive. So if two cells are connected in such a way that the positive terminal of one cell is joined to the negative terminal of the other cell, then we say such cells are said to be in series arrangement or in series connection. When two or more cells are connected in series, they make a battery. So like for this case, we can actually say this is a battery. So when you connect two or more cells in series, then they form what we call a battery. They form what we call a battery. Then connecting cells, when cells are connected in a series, connecting cells in series increases the electromotive force or the EMF, and the current in the circuit, that is the rate of flow of charge, is higher. So when cells are connected in a series, the electromotive force increases, and the current in the circuit, that is the rate of flow of charge, becomes higher. So that means if the EMF of the cell is 1.5, then the total EMF, so if we have for example, if we have three cells, for my case here I have two cells, if you have two cells connected in a series, the total EMF will be the sum of the EMFs of each cell. So if one cell has an EMF of 1.5, then the other cell also has an EMF of 1.5, then the total EMF of the circuit will actually be 3 volts. It will be 3 volts. That is, if the EMF of a cell is 1.5, then the total EMF will be 2 volts. That is, the EMFs are added. So you should also note that an ammeter is always connected in series, while a voltmeter is always connected in parallel. We gave the reason. We said that ammeters are connected in series because they only offer less resistance to the flow of charges or current, whereas voltmeters are always connected in parallel because they offer high resistance to the flow of charges. Therefore, it means if they were to be connected in series, then they will not allow current or charges to reach to other components within the circuit. So because of that, that's why we connect voltmeters in a parallel to other components. So the most important thing here to note is that when two cells are connected positive to negative or negative to positive, then we say they are in series connection. Then when components or when cells are connected in a series, the total EMF will be given by the sum of the EMFs of all the cells, the sum of EMFs of the all cells, which means the total EMF will be more than the EMF of individual cells. So when cells are connected in series, the total EMF is the sum. Sum in mathematics means addition. It's the sum of the EMFs of each cell. So for example, we have given an example here. If each cell has an EMF of 1.5 volts, then it means if there are 2 cells, then the total EMF will be 1.5 plus 1.5, which is 3 volts. If the cells were 3, then you will say 1.5 plus 1.5 plus 1.5, or simply 1.5 times what? 3. That is if each cell has the same amount of voltage. Then when cells are also connected in a series, we have said that they offer high resistance to the flow of current. They offer very high resistance to the flow of current. So that will explain why we prefer connecting cells in a parallel and not in series, because in series, when cells are connected in series, they offer very high electrical resistance, that is to the flow of charges, Then 2, we look at what we call the parallel connection of cells. Now, when do we say that 2 or more cells are connected in parallel? So cells are said to be connected in parallel when they are placed side by side, such that the positive terminals are joined together and the negative terminals are also joined together. So this is what we are saying. We have the positive terminal of this cell here. You can see it is connected to the positive terminal of the second cell. Then also we have the negative terminal of the first cell here connected to the negative terminal of the other cell. Unlike in series, where a positive was connected to a negative and a negative to a positive, in parallel, if it is a positive terminal, it is connected to another positive terminal. Then negative terminal, it is also connected to a negative terminal. So cells are said to be connected in parallel when they are placed side by side. That is, this is side by side, or when they are connected across other components or across each other. So the positive terminals are joined together and also the negative terminals are joined together. That is in a parallel connection. Then when the EMF of the cells connected in parallel are the same as for that of a single cell. Yeah. So the total EMF of cells which are arranged in parallel is equivalent to the EMF of just one cell. So if you have 2 cells, maybe each having an EMF of 1.5, then it means the total EMF will be equivalent to the EMF of one cell, which is simply 1.5. Unlike in series, where we were adding the EMF of each cell to come up with the total EMF. So we are saying that when cells are arranged in parallel, the EMF of the cell is the same, so that is the same as that of a single cell. So that means there is no significant increase in that means that when cells are connected in actually parallel, there is no significant increase in the brightness of the bulb and the current flowing in the circuit. So the current does not increase to the maximum, that is when in parallel, unlike in a series. So this also explains why cells connected in parallel offer very less resistance to the flow of current. And because of that, that means when cells are connected in parallel, they will last longer, because the resistance offered to the flow of charges or current when cells are connected in parallel is lesser. Unlike in series, where the resistance of the offered to the flow of current when cells are connected in parallel is greater. Therefore, series, when cells are arranged in series, they cannot supply current up to a longer period, whereas in parallel they can supply current up to a longer period, because the resistance offered to the flow of charges in parallel is actually small or even less. So the effective EMF for identical cells in parallel is the same as the EMF of a single cell. Then you should note that when cells are arranged in parallel, cells should not be arranged in parallel when they have so you should note that cells should not be arranged in parallel when they have identical EMFs. That cells should be arranged in parallel only when they have identical or same EMFs. Otherwise, one cell will drain current from the other. So if you are connecting 3 cells or even 2 cells in parallel, make sure they have the same EMF. Otherwise, if they have different EMFs, it means one cell will be draining the others. Then also the advantage of connecting cells in parallel is that the current is supplied for a longer time. The current is supplied for a longer time. The reason is because when cells are arranged in parallel, less resistance is offered to the flow of charges. That is, less resistance is offered to the flow of charges. So there are two common questions here. One is that you can be maybe drawn a circuit in this manner or cells in this manner. Then you are asked to calculate the total or effective EMF. So if they are in series, you simply add, you sum the individual EMFs. Then you have said that in series, cells will offer high electrical resistance to the flow of current. Therefore, in series the current is not supplied for a longer time. Whereas in parallel, cells offer less electrical resistance to the flow of charges. Therefore, in parallel, cells supply current for a longer time. Then the total EMF when cells are arranged in parallel is equivalent to EMF of each cell. We also look at connection of bulbs. So in previously we have just said that when cells are arranged in parallel, current is supplied for a longer time than when in series, since the resistance of the circuit is reduced. So we look at connection of bulbs. So of course, like in cells, when bulbs are arranged in series, they are arranged along other components. But when they are arranged in parallel, we say they are arranged across other components. So this demonstrates a series arrangement of the cell. So we have one bulb here, another bulb here, another bulb there. So this is the series arrangement of bulbs, whereas this is the parallel arrangement of bulbs. Now, what is the advantage of arranging bulbs in series or even in parallel? So the bulbs connected in series give out light of the same brightness, and when one bulb is disconnected, the others go off. So that is one disadvantage of connecting bulbs in series. That when bulbs are connected in series, they give out the same they give out light of the same brightness, and if one of the bulbs is disconnected or falls faulty, all other bulbs will actually turn off or they will go off. Whereas in parallel, that is when bulbs are arranged in parallel, the three bulbs, that is my three bulbs here in parallel arrangement, they give out light of the same brightness but brighter than the ones connected in series. So that is one advantage of connecting bulbs in parallel than in series. So in parallel, they give out the same brightness, they give out the same amount of brightness, but they are more brighter when arranged in parallel than in in series. Then when one of the bulbs is disconnected, the rest continue with the same brightness. So you can be asked, so we are saying that the same current flows through the devices connected in series. So if one of the devices is disconnected, it introduces a gap. So you can see here that in series, the current is coming from the battery. It is flowing through the first bulb to the second bulb to the third bulb. So if one of the bulbs is disconnected or falls faulty, because the same amount of current flows through the bulbs that is connected in series, therefore it means if one of the bulbs is disconnected, it introduces a gap. So if this bulb is disconnected, it introduces a gap or an open circuit. Therefore, electrical devices connected in series, they offer greater opposition resistance to the flow of current. So when bulbs are connected in series, if one goes off, the rest also goes off. Then again, because the same amount of current flows through all the bulbs, it means series arrangement of the components will actually offer high electrical resistance to the flow of current. However, if bulbs are arranged in parallel, the current flowing in one, that is in one bulb does not affect the current flowing in other bulbs. So if one of the bulbs causes an open circuit, current will still flow in other devices. So you can see here that the negative terminal is connected to our first bulb here. So this bulb is connected to the negative terminal, then again connected to the positive terminal, then this other bulb also to the negative and to the positive, this other bulb also connected to the negative terminal and also to the positive terminal. So it means if you disconnect this bulb here, actually these two bulbs will continue lightening with the same brightness. Why? Because their circuit will still be complete. So this one is still connected to the battery and also to the battery. This other one also connected to the battery and to the battery. So even if you disconnect two of them, the one that will remain will actually continue lightening brightly. Then we have also said that when bulbs are connected in parallel, they offer less electrical resistance. Why? Because the current does not flow through all the bulbs. That is the same amount of current, unlike in series, does not flow through all the bulbs. Therefore it offers less electrical resistance to the flow of charges. Then bulbs, so in series, when bulbs are arranged in series as shown up here, we have said that if one bulb is disconnected, the rest goes off, since the same current passes through each bulb. Then in series, the brightness of the bulb, that is in parallel arrangement, the brightness of the bulb in parallel is more than in series, and if one bulb is disconnected, the rest continues lightening. So you can be asked to give one advantage of connecting or to give two advantages of connecting bulbs in parallel and not in series, over series. So we are saying that the advantage of connecting bulbs in parallel is that, one, if one of the bulbs is disconnected, the rest continue lightening. If one of the bulbs is disconnected, the rest continue lightening. Then two is that when bulbs are arranged in parallel, they give more brightness, or they light more brighter than when connected in what? In series. So that is how we connect the bulbs, that is in parallel and in series. So we have also said that because the same amount of current flows through all the bulbs in series, therefore bulbs in series will always offer high electrical resistance to the flow of current. Therefore it means the battery will be drained faster when bulbs are connected in parallel in series than in parallel. Then if you had individual switches, remember in parallel bulbs can also be controlled using individual switches. Therefore if one bulb is switched off, the rest could actually continue lightening. But in parallel, the bulbs can only use one switch, such that if you put off the switch, all the three bulbs actually goes off. So in domestic electrical wiring or in the lightening circuit, bulbs are connected in parallel. So the reason is usually simply because the three bulbs or the bulbs can be switched on and off independently, and one bulb blowing out does not affect the working of the remaining bulbs. We look at an example involving a calculation of the total EMF when cells are arranged in parallel and in series. So the example actually reads that three cells have an EMF of 1.5 volts each. What is the total EMF when the cells are arranged in A in parallel and B in series? So we have just said that in parallel arrangement, the total EMF is equals to the EMF of each cell. So if you are being told that three cells have an EMF of 1.5 volts, then in parallel we are saying that total EMF is equals to EMF of one cell. By the way, why is it that in parallel total EMF is equals to the EMF of one cell? The reason is simple, because all the bulbs or all the cells, all the components draw voltage from the main supply, whereas in series the voltage has to go through one of the bulb, then some voltage will be lost, then the one that is remaining is what goes to the second bulb, that which the one that remains after the voltage that dropped at the first bulb and the second bulb is what reaches the third bulb. But in parallel arrangement, all the bulbs draw their voltage from the mains. That's why the total all components will be at the same EMF as the total EMF. So in parallel, total EMF is equals EMF of each cell of one cell, which is equals to 1.5 volts. Then in series, we have said that total EMF will be equal to sum of the EMF of all the cells. That is the voltage drops across each bulb or across each component. So the sum. So if, because there are 3 cells, it means the total EMF will be EMF for one cell plus the second cell plus the third cell. So that is 1.5 plus 1.5 plus 1.5, which actually amounts to 4.5 volts, which comes to 4.5 volts. So I have an exercise here which I recommend that students should try and see whether they understood our previous example. So the exercise actually reads that 5 cells have an EMF of 1.4 volts each. Find the total EMF when the cells are arranged in A parallel, B in series. So I've worked out, and the expected answers are: in parallel is 1.4 volts, in series is 7 volts. So we've come to the end of our class today, but we need to discuss the quote of the day. So the quote of the day stated that if it does not challenge you, then it will never grow you. So the quote simply means that, one, you should not run away from challenges in life, because when you go through a difficult moment, that is how you learn. The lessons that you obtain from such a situation are the ones that help you to move on and even do it better the next time. So remember this, that challenges makes life interesting, and overcoming those challenges is what makes life meaningful. So in life, you should be like a tree which is oftenly struck by strong rays of light from the sun, and even gets rained on but by heavy rains, but uses the same light from the sun and the waters from the rain to grow itself and even produce fruits. So the plant is seeing that it can use what had come to destroy it positively. That is, it is being rained on and even shined on by strong rays of light, but it is using those rays of light for photosynthesis and even using the waters to grow itself and even be fruitful. And remember this, the best revenge in life is not paying back hatred with hatred. So the best revenge in life is massive success and showing kindness. And remember this lastly, failure should not be the end of your story, rather it should be the start of your comeback story. This is Kind Tuition Academy. Kindly hit that subscription button on YouTube. Thank you.